So we've seen static routing. Static routing lets me actually configure up where the next hop is manually. Again, on a small network that works very well, but probably as we scale up, we'd want to work with something a little bit easier, something a little more automatic. That would be a dynamic routing protocol like RIP, EIGRP, or OSPF. Let's take a look at how the RIP functionality works within our infrastructure. So static routing is manual. We have to do it ourselves. Dynamic routing means that the routers will actually talk to each other and figure out how the routing paths should go, where the next hops are. So for our dynamic routing protocols, we have several different kinds. We have distance vector, which is RIP, Routing Information Protocol, and that's what we'll take a look at now. When we configure a dynamic routing protocol, we need to specify which routing protocol we're going to use. So we'll use a command like router RIP to turn on RIP routing. And then what we need to specify is which networks are going to be participating in RIP routing. So if I look up here at R1, for example, I have two different networks defined in R1. I have the 192.168.10 network, and I have the 192.168.20 network. So for R1, I would also need to specify which two networks that we want participating, or which two interfaces we want participating. And we do this with just the classful network boundary, 192.168.20 and 192.168.10 in the case of R1. I don't need to put any mask in here. We'll find that we can actually put the mask in here if we want to, but we don't need to. For all intents and purposes, what the router does is it looks at the subnet mask that's on the interface and it applies that when it does its updates. Well, I suppose we can go back and say with RIP version 1, which is what I have configured here, it doesn't even pass a mask. So RIP version 1 is only classful. RIP version 1, RIP v1 is classful, which means it can only advertise classful boundaries. It only supports FLSM, fixed length subnet masking, so it can only go on the classful boundary. What we will do eventually is we'll switch over to RIP version 2 in the same configuration by just specifying the command version 2, and that will change this instance into version 2. So RIP is only one executable that's running. It runs in two different versions, and you cannot run both at the same time. If RIP is running by default, it's broadcast based, and it does not pass the subnet mask information in its updates. If I type the command version 2, it actually updates the current running version and makes it multicast based and allows me to pass the subnet mask in its updates from router to router. So let's take a look at a configuration, how we'd set RIP up to run. Remember, what we want to do is just specify on R1 the directly connected networks that we want participating. So I'll jump into router 1 here. In router 1, what are we going to do first? Press return to get started. You love it when the screen tells you what to do. Password was console. Enable. Password is Cisco. For me, may or may not be in your environment. Let's do a show IP route to see what we know about. And right now, this router only knows about the 10 and the 20 network. As predicted, the 10 and the 20 network are the only two that router R1 knows about. We ultimately want to know about network 30, which is going to come from R2. So to do that, we are going to get router RIP up and running. We want to go into global configuration mode first, and then into router RIP configuration mode by specifying the router RIP command. Notice that my prompt changes to config-router. I'm configuring RIP now. And our configuration is just to simply specify the two networks that we want participating, which would be 192.168.10.0. Again, I don't need a network mask, a subnet mask, or anything in here. Network 192.168.20.0. And that's all it takes for RIP to work. I'll save that configuration just in case something bad happens. Let me put this down, take a look at my router, go back and do a show IP route. What would you expect to see? If you said no change, you would be correct, because we only put entries in here that we've learned from another router. If we haven't configured R2 yet, then we're not going to see any updates. Right now, R1 is actually propagating out both of its interfaces the appropriate updates. However, R2 is not listening yet, so we need to jump into R2 and make the same changes and configure RIP so that we have two routers participating so we can get those updates. So if I jump into R2, enable password with Cisco, if I do a show IP route, sure enough, I only have my 2 directly connected networks, and again, as expected, that would be the 20 and the 30 network, and those are the 2 that we want participating. So I will go back into global config. I will configure my router with the router rip command. I'm at my config-router prompt. I'm going to specify the 2 networks, 192.168.20.0 and network 192.168.30.0. Exit out of there. Show IP route. And now what will we expect? I would expect to see a RIP entry learned by router 1, which would be the next hop of 20.1 that tells me where the 10 network is. So now dynamically, router 2 has learned about the networks on router 1, and hopefully router 1 with a show IP route has learned about the networks that router 2 has to offer. Perfect, so RIP is up and running, and now we can work our network. If we were to add another network at some point, I could just specify a network statement in the other router, and it would propagate through the entire infrastructure, and all the routers would ultimately, the term we would be using would be converging or converged. So I'm in the process of converging when I'm learning about all the networks and all the routes. I am said to have converged when I've learned everything I can possibly learn. Right now, our network has converged because we see the 10, 20, and 30 network, and we only have the 10, 20, and 30 network in here. If you want to verify on a router what is actually running, you can do show IP protocols. This tells me that I am actually running RIP with my updates, which interfaces are running, which networks are participating, and which version of RIP I'm using, version 1. Again, this is a broadcast-based component, which means I'm not passing any subnet mask information. If I want to switch to version 2, which we would typically do if we're using RIP, then we need to specify that version 2 command in here. Nothing will change in my route table, but I need to go back into router RIP configuration, router RIP, and type in version 2. That makes this router running version 2. I'll save that as well. We will jump into R2 because we don't want to have any issues. Conf T, router RIP, version 2. Now we're back being consistent again. Show IP route, nothing should have changed, and it didn't, thank God. And there's nothing in here that tells me which version I'm running, but now if I do a show IP protocol, we can see that I'm actually running version 2. All the other information in here is exactly the same. Again, what version 2 does for me is it changes to a multicast address. It uses the multicast address of 224.0.0.9. 224.0.0.9 is the well-known RIP multicast. And with version 2, it's sending out classless updates, which means I'm passing the subnet mask. Let's try that again. Passing the subnet mask. So, makes our life a lot easier. Once it's configured, it dynamically learns, hence the dynamic routing protocol, and that's a little bit about RIP configuration.